So, I was actually a student of Paul's and Miguel's years ago back here in SARC, and even the work of Francisco and Barry as well really influenced some of the stuff I did, so it's cool to be back here. But since then, I've turned to the dark side of making commercial products. So I make things that add value to shareholders rather than the benefits of academic music. But as part of that, I've had the opportunity to make musical tools and put them in the hands of lots of people and really learn how they use those. So it's been a really enriching experience. So I've been involved in the designing, development, manufacturing, testing, marketing, and selling of Mogees. Mogees are these little guys. They are vibration sensors, is what we use for marketing terms, is an easier way for people to understand contact microphones. They're just contact microphones that you can plug into a smartphone or into a mixer or into a computer. And it comes bundled with some, whoops, that's probably gone to the bottom. Bundled with some software that performs some machine learning techniques as a core part of the product. So I'm going to use a quick demo video to save me from having to set it up really quickly.
Mogees allows you to transform anything around you into a musical instrument by combining a vibration sensor with intelligent music software. The vibrations you create are analyzed and converted into the sounds you want instantaneously. Okay, so that's cool.
Right. Sorry for the Pan-American accent that I put on for the advertisements. So, yeah, I don't really know all that much about machine learning. I started off just messing around with some of the tools of Nick Gillian's gesture recognition toolkit and Rebecca Freeberg's Wekinator and stuff. But thankfully, we put together a team of much smarter people than I am to really make something cool. But when we started off, we cared about what would happen if you applied a physical model and using a contact microphone as the input to the system. So I don't need to explain physical modeling to a lot of you, but if you imagine that instead of digital exciting mechanism, we actually use the contact microphone on the object as the exciter. And even if you just use a straight up string model, that can be a really, really powerful thing for you to be able to scrap and tape and get all these amazing sounds out of it. And even just that experience, putting that in front of a musician who isn't familiar with physical modeling, is kind of an eye-opening experience for them. The next stage for us was, okay, how do you actually control that pitch? So how can you use the contact microphone not just as a input to a synthesis model, but also as a control mechanism? So again, if you think about the sounds of, there is so much information in a tiny little frame of sound happening there that you can rapidly analyze and apply all of your machine learning magic to use it as a control mechanism. So everything vibrates when you touch it. Everything vibrates when you interact with it. And a lot of those vibrations are obviously going to be inaudible to you unless you use this kind of contact microphone as your magical ear. We got Andy Farnell, the pure data guru, to design some really nice physical models for us. And we had Carmine Amamachella and Baptiste Caramio and who am I forgetting? Juanjo Barred were parts of the team who managed to make some really, really magical stuff for us. If we think about what musicians demand in a musical instrument, they obviously require super low latency, they require reliability, and they require expressivity. And these demands are much, much higher for musical instruments than when you think about traditional HCI, when mouse and keyboards and things like that. So we figured if we can nail all of those three things, we have made a controller that is very, very powerful, but also has this very small form factor that you could attach to anything. So there was a couple of things that we had to make sure worked first. Once we figured out, all right, we're going to use this contact microphone, we're going to stick it to things, and it needs to be able to work on any object that you attach it to. How do we do that? We go out and we record hundreds of objects being tapped thousands of times. We hired a guy to go crazy and tapping objects for a whole month. And we use that database to build up an understanding of all of the parameters for our analysis methods in order to make that work. So we're like, cool, tick. It will work on anything that is going to be firm enough to resonate even a tiny bit when it's struck or hit by a user. So that kind of ticks that every object sounds different. The next challenge was kind of teaching the user, not teaching the machine, but teaching the user how to teach the machine. And this keeps on popping up in the discussions that are showing up today, is that the way that Mogees works is that it identifies the differences in the sounds that you make. I think the soft limit conceptually for people is like up to 5 gestures. So gesture 1, gesture 2, gesture 3, gesture 4, gesture 5. That's how I would train it. There's 2 phases to it. You need to first train the system with, I think it's 10 or 12 onsets. And you need to build up this training model inside the software before you can then move to the performance stage. So the first question that you need to teach the user there is, what is a valid gesture? What's a good gesture? And they need to do this bizarre thing where they need to think about themselves from the point of view of the machine. And when I started off trying to develop even just the tutorial materials for Mogees, it was tricky in just saying, oh, just imagine that your ear is where the sensor is. Because people don't think about it like that. They can understand the concept of position. So like, okay, I hit here and I hit here, that should work. And oftentimes that does work because of the timbral differences between this point and that point. But it doesn't necessarily work if they then go, oh, that was left and right of the sensor, so if I play left and the right of the sensor, it should still work. Obviously not. And timbral differences will make sense for them when it comes to, oh, the sound of your thumb versus the sound of tapping it with a pencil or something. But then they're like, I've got 2 hands. I don't have like an array of these different materials that I can hit with. And we were even considering for a while shipping Mogees with these little different exciter rings made out of different materials that could have been quite nice. But that kind of went against the idea of you can turn anything into an instrument and the affordances are set by you. You decide how you want to play it. So Baptiste came up with this kind of on-screen visualization that I thought was quite, oh, there's version 1. Yay! How awful is that? Baptiste came up with this idea of visualization of training blobs. So using some of the same techniques that we actually use to do the classification of different gestures, he developed a system that gave these little dot representations of how distinct or similar gestures were from the machine listening model's point of view. And eventually construct these little circular blobs. So if the blobs, if you train 2 gestures, so gesture 1 and gesture 2, if they're nice and distinct, they're distinct enough to the system to understand them as unique. If you were to train gesture 1 and gesture 2 and they ended up being quite similar, those circles would overlap. So instantly the user has this, direct visual feedback of something where they can comfortably know that they're doing a good job and the machine is good job. The problem then, after that, is users obviously, they perform differently than they train. So since this is kind of a 2-part process, they train the system and then they go off and perform. So if I think about the kind of pro musician person that's bought Mogees, they've put it on their weird object on their table, they train their gestures, the sound check's over, they go off, they have a couple of beers, they come back to the mixing console or whatever, to the desk, and their gestures, which they once trained as 1, 2, 3, have now been moved over here, and they're like 1, 2, 3, or even worse, they've picked up the microphone and moved it slightly, and that entire timbral model that was trained by the machine learning has kind of fallen apart. And to the user, that's a bizarre thing. It's like, but it's exactly the same, or I just moved it slightly, or it was to the left and to the right, wasn't it? But that's not quite how it works, and we have to really whip the user into learning how to suit the machine's needs. And obviously, this is the worst style of user-centered design you could ever imagine. And this is kind of what has to happen if you're working on a new technology that is dictated by the machine. So machine learning can perform all these sorts of magical tasks and of great promise when it comes to optimization and organization. But when it comes to real-time HCI, the same classic challenges of user-centered design when it comes to digital interfaces applies. We can't ignore them. And our kind of next phase at Mogees is obviously focusing on these real-time HCIs, the portability of taking emojis and being able to put it on any object around you. But we need to focus now on how do we either reduce or entirely remove the calibration process so that the user can walk up to this object that they want to control and really take it on their own terms and define their interface in such a way that it won't cheat them when they come back to them. So I'm going to wrap it up there. I'll play a funny video just to show you what I mean by what users really want, because a lot of the time people purchased emojis after seeing these cool videos of like gesture 1, gesture 2, oh, see, he's got a kick drum and a snare drum, that's awesome, I want to buy one of these. And then they play it and they're a little bit confused by it or something, and they watch tutorials and they're like, oh yeah, that kind of works, but what I really wanted was a velocity sensitive button. So we've actually made 4 apps that use it as a velocity sensitive button because it's a business. But we still have a lot of faith in the HCI implications of using machine learning in this snapshot real-time mechanisms. And plug, we're hiring, so if you know any smart dudes that want to help out in this pursuit, that's going to be great. But let me quickly finish off by showing you what I mean by what people really want when it comes to new interfaces.
Mogees is a new sensor and app that can turn anything into a musical instrument on the fly.
What's up?
What's up, Robert DeLong? How you doing?
So good. Ready for your first music lesson?
Yeah, do you have any instruments?
We don't need instruments. We're gonna play the car.
A car? What's wrong with you playing right now?
Nothing. Check it out.
Alright, baby, whatever you say, man.
Yo, let's make you into an instrument.
Sure. Wow, I'm a music instrument.
Years of academic research leading to that point. Anyway, thank you.